Hello everyone, this is Group 1 presenting on our first lab of the semester, Lab 1, dealing with logic gates, the laptop fan alarm circuit, and logism. In our group we have Javier Benitez, whose picture is on the far left, Freddie Kawaku, whose picture is on the bottom right corner of the screen, and my name is Evan Harrison, and I'll be doing the voiceover presentation, and my picture is up in the top right corner. So we broke this presentation up into three parts. First, we'll discuss the brief review we had on the logic gates, the basic logic gates. Then we'll talk about the equations that we received for the laptop, fan, and alarm circuits and the simplification there. And then we'll discuss our logism implementation. So first, we had to review several of the basic input, 1 to 2 input gates. The first one was the NAND gate, which basically produces a high output when 0 or any other odd amount is high, as shown in this truth table, as any odd amount of inputs, I should say. Next, we did a review of the NOR gate that has a high input when all other inputs are low. And then the NOT gate essentially just inverts the output. And then the AND gate is high when all other inputs are high. The OR gate produces a high result when only one or more inputs are high, including both inputs. And then the exclusive OR gate only produces a high result when an odd amount of inputs are high, in this case with a 2-input gate. So the second part of the lab, we were given a truth table for the laptop microprocessor for the alarm and fan circuits. We were given that truth table and told to write out the equation for the fan output and the alarm output. And here we see the equation for the fan output. The trick was to find the outputs of the fan that produced a 1 value or a true value. And once we got that equation, as we can see in the left here, F equals C, not C, and not V and T, or C and not V and T, or C and V and T. Once we got that equation, we were told to simplify that. And the trick to the simplification for the fan was to duplicate the C and V naught and T term. And once we did that, in this step, we were able to pull out the not V and T, and the C and T from the terms, leaving the not C and C, and leaving the not V and V. And those two terms were able to simplify to 1, which gives us the result of not V and T, or C and T. And likewise, we did the same thing for the alarm circuit. However, the lab gave us the equations for the alarm, as well as the simplified version. As you can see in the bottom here in red, the alarm is represented by the equation not C and V. And here is a quick screenshot of the web page we used to simplify the results. To apply those into iLearn. It gives us the same equation, just in a different rearrangement. Now for part 3 of the lab, once we got the equations simplified, we were told to implement the equations using logism to create a diagram, the circuit diagram. And we used the most simple versions of the equations to produce this diagram. Other equations could have been used and produced different diagrams. We can see the alarm with the equation not C and V. That's represented here with this AND gate, along with this inverter nodding our C and our V term, which is our low voltage, right here. As well as the equation for the fan is implemented right here. We've got our AND gate for our cord and our temperature. We've got our AND gate for our temperature and our low voltage. We've got our inverter to not our voltage. And then we've got our OR gate, taking the combination of those terms to produce the output for the fan. So for the alarm, we had two true outputs. The first true output occurs when our voltage is low, when that is true, and the other terms are false. Our chord in this case is false. We can see our output is 1. And we also got a true output for the alarm when our low voltage input was true and our temperature input was true. As we can see in this diagram, those are true, and our alarm output is also true. For our fan, we got 3 true outputs. The first occurred when the temperature was true, when we had a high temperature, and we can see that here, that the fan output is true. Also, we got a true output when the cord was plugged in or unplugged, and so we have a true value here. And with our temperature, we also have a true value, and our low voltage at 0. And again, our fan is true. And finally, the last condition that causes the fan to register as true is when all 3 inputs are true: the cord, the temperature, and the low voltage. So in conclusion, the lab was fairly simple, fairly straightforward. It helped us become more familiar with each of the basic logic gates. It also helped us see the benefits of simplifying Boolean expressions. And then it allowed us to apply those simplified Boolean expressions and create a digital circuit that helped us to solve a real world problem. This was Group 1's presentation.